Let's balance another equation by the half reaction method. This is number 13 from the extra practice that's posted on the website. First thing I'm going to do is split it into an oxidation and a reduction. So we're going to break it into a chromium piece and an iodine piece. So we're going to have Cr2O7 yields Cr plus 3, and we will have I2 yields IO3 minus. Here, I have 2 chromiums on the reactant and 1 chromium on the product. So I am going to need to balance that first, because in solution there aren't extra chromium ions that I can draw from. So I balance the chromium there. Then I need to fix the oxygens. In order to fix the oxygens, I'm going to add waters. Those are in solution. So I will add 7 water molecules to this side. Now that solves the oxygen problem but creates a hydrogen problem. So 7 hydrogens, so I'm going to come over here and I'm going to add 14 hydrogen ions to balance out the 14 hydrogens from the waters. And then I need to balance it in terms of charge. It's balanced in terms of atoms. This side right now, so water's neutral and chromium is plus 3. There's 2 of those, so it would have a charge of plus 6. The Cr2O7, I dropped its charge somehow, so it's still minus 2 as it was in the original problem. So we have 14 hydrogen ions, so each one has a positive 1 charge, so that's going to be 14 plus with the single 2 minus, so this side is going to be positive 12. I will add electrons, which I'm going to ultimately be getting from there, well, giving to there, to the more positive side in order to balance the charges. So I am going to add in, and then this is going to be just all, so I'm going to add 6 electrons to this side, right? 6 electrons would be minus 6, that would make that plus 6 and plus 6 and plus 6, so it's balanced in terms of charge. Now let's go fix that iodine one. Same situation as in the chromium one. You have 2 iodines and a single iodine in the products, so I'm going to put a 2 there. So now I have 2 iodines on each side. That would give me not just 3 oxygens, but 2 sets of 3, so that's 6 oxygens on the products. So to solve that, I'm going to add in some waters. It's going to be 6 waters to the reactants. There are no hydrogens on the product, so I'm going to come over here. I'm going to add 12, 6 sets of 2, so that's 12 hydrogen ions. And now I need to balance it in terms of charge. Water's neutral, elemental iodine is neutral, so that's going to be 0. And then this side is 12 H pluses, and then 2 iodates, each with a minus 1, so this side is currently plus 10. So that means to balance out the charge, I'm going to need to add 10 electrons to the product side. Now, my goal is to take these 2 half reactions and put them together into one equation. When doing that, the electrons that are being transferred have to cancel. So this has 6 electrons, this has 10 electrons. So the least common multiple of 6 and 10 is going to be 30. 30, so 10 times 3 is 30, 6 times 5 is 30. So I'm going to take this whole equation and multiply it by 5. And I'm going to take this whole equation and multiply it by 3. So then there's a bunch of writing. So I'm going to rewrite all of that so it would be 30 electrons plus 70 hydrogen ions plus 5 Cr2O7 minus 2s yields 10 Cr plus 3s, 35 H2Os, and that's it. All right, and then we'll do the iodine one. It's going to yield 6 times 3, so we have 18 waters plus 3 iodines yields 6 iodates, 36 hydrogen ions, and 30 electrons. And the whole point of all that multiplication was so the electrons would cancel out. 30 electrons, so goodbye electrons. And then I am going to combine all of the reactants and all of the products into one big equation. So that's going to give us 70 hydrogen ions plus 5 dichromates plus 18 waters plus 3 elemental iodines yield 10 chromium ions, 35 waters, 6 IO3 minuses, and 36 hydrogen ions. Then there's a little bit of reducing that can happen. So we have 70 hydrogen ions on the reactants, 36 hydrogen ions on the products. That means I can get rid of 36 of those ions on each side. So 36 is gone, and 70 will be reduced down to 34. We'll write it down here. 34 hydrogen ions. And then waters will do the same thing. There's 18 waters on the reactant. There's 35 on the product. And so I can get rid of 18 on each side. So that guy's gone. And then 35 minus 18 would be 17 waters. And then I'll rewrite the whole equation. So Cr2O7 minus 2 plus 3 I2s yields 10 chromiums, the 17 waters, and the 6 IO3 minuses. Now, we might want to know or double check that this is correct so we can make sure that it is properly balanced in terms of atoms and charge. The charge on the reactant side, you have 34 hydrogen ions, so that's positive 34. You have 5 of these dichromates, so that's minus 10. This guy is 0, so that's going to give the reactant side a charge of positive 24. And then the product side, you have neutral, 6 of the minus 1, so that's minus 6. You have 10 of those, so that's positive 30. Positive 30 minus 6 is positive 24, so charge is balanced. And then atoms are also balanced. You have 17 oxygens. You have 17... No, you have more than 17. You have 17 and 18, which is 35. Over here you have 5 times 7, that's 35. So, yeah, it's balanced. If the oxygens check out, it's most likely balanced. You might also want to figure out which species is undergoing oxidation and which species is undergoing reduction. To do that, you can look at the reactions where you had electrons, or you can look at the initial problem in the first place. Since iodine is reacting with oxygen, it is being oxidized, right? It is reacting with oxygen. Or you can look at its oxidation number. Its oxidation number here goes from being 0 to being, what would that be, positive 5. So if the oxidation number rises, then it's being oxidized. If you look at the chromium in the dichromate, it would have to be, let's see, 7 oxygens would give you minus 14 up against 2 chromium. So each chromium would have to be plus 6. So chromium is going from plus 6 down to plus 3. Its number is falling. It's being reduced. Or you can look at the electron reaction. This reaction was gaining electrons. That's reduction. This reaction was losing electrons. That's oxidation. So it's a couple of different ways you can identify what's being oxidized and what's being reduced. Hope that helps, And if it didn't help enough, let's watch another video.